Talk about persistence.
All right. Here's the error bars.
I'd like to go over something with you, if I may.
26. All right.
Talk about persistence.
All right. Are there any questions or comments?
Yes, I have a comment, and it's about the Blinn Mountain from Edith's Hook location.
Are there any questions or comments from people that are actually invited to the Celestial Theodolite updates?
Well, you're strawmanning my data that I provided, okay? You're misleading people. So it's...
That's weird. I said that's so weird. I said, are there any questions from people that are invited to participate?
I didn't hear anything, to be honest.
And then the person who wasn't invited was still talking. So weird.
Yeah, we addressed his strawman argument, I think, because there's no way to possibly strawman it this way. And at this point, if there is a new method, let us know where we are. But these ridiculously vague, just strawman claims without saying, hey, when you're representing the angular drop with your half of the angle arc formula or whatever, then that's not correct. That's one thing. If you're saying, hey, the drop over distance calculator you're using is not, this derivation, it comes out to something different. Great, that's another thing. If you're just saying that with none of those, then we don't care.
And like I said, if there's another formula to use that we should be using, hit us up. Like we'll adjust it. Because the issue here doesn't seem to be the math. It seems to be that the occlusion timings don't line up with the globe. The error is always greatest on the globe side because there was no geometric intersection at the time predicted.
I remember update 2, 3, and 4, the Globers were accepting everyone was on board with it. They were excited. No one was teleporting. Everyone was agreeing with it. But then the implications started to set in, and then these ridiculous backwards objections started to happen. And now no one accepts anything about it, which is a weird position because they were all so enthusiastic in the beginning. If anyone remembers, someone should go watch 2, and 3, and 4.
And compensating for refraction, there's still a timing tolerance that needs to be fully compensated for, because otherwise you're just arbitrarily cutting off your refraction short to say that it just so happened to match a flat Earth coincidentally.
You really should fix the globe prediction for the Blinn Mountain site. That you've got that just wrong. And you know it too, because you know that's why I went to that location, was because the angle given by Stellarium when set to the peak with atmosphere off was going to match the expected geometric globe angle to that mountain from that location. You know that's why I went there to get that. So why do you show some other predicted globe angle in your spreadsheet? That's not even honest.
You're not honest, Jesse. Shut up.
Well, do you know why?
I cherry-picked that observation just for that very fact. Now look.
No, adding to the pool is not cherry picking. If I had hidden his results and only showed ones that matched the globe, then that could be called cherry picking. But the point is, Dr. Heffron himself said that he tried to refute his hypothesis, right? So if he tried to refute his hypothesis and he said he was unable to refute it, then why is it wrong for me also to try to refute his hypothesis? That's not cherry picking, that's trying to refute the hypothesis, just like Dr. Heffron himself said he tried to do.
Nothing wrong with trying.
Okay, good.
Hey, Jesse.
Hey, Rick.
Did you say the other day that they changed the formula for each observation?
There was a point in time when Dr.
Did you say the other day that they changed the formula for each observation?
There was a point in time when Dr. Hef
Uh,
and I have evidence. I saved a screenshot. Actually, you could get the PDF from Dr. Heffron yourself, but I saved a
Hey,
screenshot
Jesse,
of it.
when
Yeah.
you say that, like last time you spoke, because Rigger and I were here having a little bit of a yarn with you, and you just said that they seem to do it. Well, they changed the formula each observation. You never mentioned that. Oh, well, they did at one point and then they changed back. You just carte blanche just made that statement, right?
No, I told you that at one point they had put a custom correction to each observation to make it match the flat Earth, and I've
You
got evidence of
specifically
that.
think that you said that, do you?
I do. And I also told you that at one time they had told me that
Dude,
they
how do
had.
you do it?
Hold on.
How
How
do-
do you
how-
how
dude,
did you
how do
learn
you do it?
how did you get to the age of having a driver's license without knowing to take turns? I really would like to know that, but I know you couldn't tell me that. But I also told you that at one time that they told me that they had solved the problem in their method that caused such huge errors, but they wouldn't tell me how they solved it. It turned out they had not solved it, but I didn't find that out until later.
Dude, all of your accusations are just so bizarre.
Yo, we don't care about your opinion, Rick. Go on mute, please.
Nice one, Gage.
Bizarre or not, but if I can back them up, they should concern you, right?
I don't think you at all said that. Oh, well, they changed. At one point, we're using different formulas, and then you change your statements around all the time, dude.
Oh, bring
Have
your
you
evidence.
got like a little sort of documentation? Bring my evidence, dude. You said it. What was it? I'm gonna have to start recording you now.
Definitely.
This
Go
is
for
what's.
it. Absolutely.
It's just so sad.
Please do. In fact, I wish you would have recordings for everything you purport to quote from me, with context. Because when he did it, when he initially was, his initial idea was a good one, to use stellarium set to the observer location as in place of a theodolite. It was originally a good idea, but that gave globe results, and he didn't like that. So he found out that by turning off refraction and moving it forward to add in 1 degree per 60 nautical miles, that therefore he could get it to match the flat Earth prediction more or less for certain mountains. I'm pretty sure that either he was hired by globers to make flat Earth look bad, or he was hired by flat earthers to try to prop flat Earth up. I'm not sure which. But he knows better. Definitely he knows better, but he's just not letting it on.
The whole point of the observation is the occlusion. Once the star is not seen anymore, that time is recorded, correct?
Correct. Or in my case, I was doing emergencies because I was
Emergencies.
looking eastward.
And so, like, that's another question I had for you, because wouldn't you want to do a longer distance observation so that you can have a distinguishable amount of separation between globe and flat?
Longer than what?
Like say 50 miles?
Most of theirs weren't 50 miles, and in fact, the difference between globe and flat at even 25 miles is 131 meters, which is well within the capability of this method to differentiate.
So
Yes.
what's your longest distance of observation of a emergence?
25.4 miles, I believe it was.
Okay, so you're using the method.
Yes.
So what's your problem with the method then? Why do you continually say
it doesn't work?
It doesn't work because it doesn't work for the globe.
Doesn't show a globe.
That's why it doesn't work.
Right.
Well, what do you mean? In my case,
what do you mean? What do I mean?
Hear me out.
The internal timing is planar.
Was it a plane second?
No, it's planar. I'm saying when you do the
planar
internal
second,
timing
yes.
itself. Yeah, not
Was
like
it
not
planar?
optical. Yeah, not optical based, but the actual timing itself. It's like if you call that like an internal timing, meaning it's like internal to the system. That is what reveals the planar geometry.
Well, in my particular case, I was 25.4 miles away from the mountain, and I filmed like, I think 14 stars rising behind that mountain, and that I was able to identify later in the video. And they all matched the globe prediction for the elevation angle to that mountain. So that's my problem with the method, is it depends on the distances and altitude differences involved, and it's like a smorgasbord. You can get all kinds of different results that match flat or match globe or match a tiny globe or match even concave. So that's my big problem with it, is it doesn't work. It is not predicted by arctangent of rise over run.
So if it doesn't work, then why do you care? Like, why are you trying to prove that it's closer to the globe? Like, if it doesn't work, then it doesn't work. Like, you shouldn't even be worried about whether or not it proves globe or flat. You should just be like, this doesn't work.
Is that it doesn't work. I do not present it as globe evidence, not using their method.
So you don't believe in planar trig.
Jesse, so
That's
you
what they're-
found out that that it doesn't work for the globe and decided just to dismiss the whole method and say the method's invalid? Because that wasn't what you were saying originally.
Clip it for me, please.
So
Oh,
your
yeah.
claim is that they're intentionally misleading people knowingly, which is dishonest lying. So they're lying to people to make them think that it's flat, even though they know otherwise. Is that what I just heard you say?
Well,
Could have sworn I didn't hear you say that, right? But I did, though, right?
if they say that the Blinn Mountain the Blinn Mountain from Edith's Hook is closer to flat than closer to globe, when they know that it's not, then wouldn't that be a lie? Yes or no?
Weird, because there's been, what, like 30 of these presentations so far? And how many times has it been acknowledged that you are able to find a relationship such that the half angle correction is at correct height and distance close to the drop over distance expected on a globe, so that at that particular set of distance and elevation it will appear to be closer to globe than flat? That's been acknowledged many times. So for you to claim that they're just unequivocally stating that every measurement matches flat and not glob is a willful mischaracterization of the actual presentation.
I sure thought I heard Alan say that today. I'll have to go back and clip it. Fortunately, I left a comment in the text at that time, so I got a timestamp of when he said it. So I will definitely go back and try to find that. Does anybody else here remember hearing Alan say that some of the data points do match the globe more closely than the flat?
It's super odd that you also wait until after Alan leaves to do this every time.
No,
Well,
he
he-
didn't either. He tried and he
He's
got
technically
muted
not
as soon
allowed
as
to
he
talk
tried.
anymore because he's
Yeah,
so dishonest. Because of this shit so
I
much,
mean,
Alan's
last
just
week
not putting up with it
he
in
did
conversation.
try. He did try when
Yeah,
Alan was here, but I did hear Alan say last week though that none of them matched the globe better, and they all matched flat Earth better. So
Yeah,
So I'm not.
specifically on Blinn Mountain, I'm pretty sure that the spreadsheet that he showed in the presentation clearly shows that the magnitude of the celestial refraction correction is over twice the predicted drop over distance of the globe. So they're literally incorporating a quote unquote celestial refraction correction that's over 2x the geometric drop of 8 inches per mile squared. So
So
it's
Piezo,
uh,
I did try bringing this up during the open Q&A today, and Alan immediately muted me and did not unmute me until he left. So that is why I'm talking about it after he
it's
left.
probably because of the 27 other times that you've just been incredibly dishonest and bad faith that you've, just lost your privileges on his presentation. I would say that probably has something to do with it, wouldn't you?
Nope, I know exactly what it is. It's because a few weeks ago, after the show, I demonstrated the huge errors in his method, and he was mad about it.
Oh, that's what he's mad that you're so good and he's so wrong, and he just can't stand that you're just better, and he just mutes you because of that. Is that what you're purporting?
Sure, but if you're willing to go over this Blinn Mountain and Edith's Hook data with me, I would be very honored. People keep telling me I'm wrong, but nobody will step up to the plate. That's the problem. So what are people to think when everyone who tells me I'm wrong won't bring their receipts? I got receipts for what I'm claiming. Nobody will bring their receipts. What's people supposed to think about that? Who's the honest one here when no one else will bring receipts?
Jesse, just so you know, I intentionally unplugged from this endless debate over Cell-Theo after we reached the juncture of where we were back in the month of June. Because if you remember, which I'm sure that you do, back in June, you produced a simulator using the globe prediction along with terrestrial refraction, and then after taking that resultant angle, multiplying it by celestial refraction to get a final apparent angle. And when you did this, your simulator perfectly predicted pretty much every measurement Dr. Mike and company had taken. You remember that?
I do.
And so, yeah, at that point, we were like, huh, that's kind of weird. So, you know what we did is we looked into it and we were like, what is this extra correction on top of refraction called celestial refraction? Why are they incorporating refraction twice? So then when we looked at the historical development of celestial refraction as well as the formulas used, I immediately realized, oh man, this is not a general solution using the fundamentals of physics. This is literally an empirical force fit to a curve. Because what actually happened was they didn't have such a thing as celestial refraction. They just had real refraction, aka Snell's law, and the globe prediction. And when they plugged that in, they were off. What ended up happening is they went out into the real world and they took a bunch of measurements and they plotted them all along a curve. And then they took their theoretical predictions for what should have been measured at that curve, and they realized these two curves do not match. So then they took the difference between those two curves and fit it to a second order polynomial, a quadratic curve fit, and voila, it popped out a formula. And that's the formula they multiply the resultant angle by to force real observations to conform to globe predictions, because they don't conform. And that is what celestial refraction is. It doesn't have a single physical variable. It doesn't account for temperature. It doesn't account for pressure. It doesn't account for atmospheric conditions. It doesn't actually have any units in it of any kind. It's just take the angle, put it in a second order polynomial in the numerator and denominator, and multiply it out, and it'll transform your angle that you measured into the angle the globe wants it to be. That's what celestial refraction is. Once I found that out, I was like, oh my gosh, they're cooked. This is what they did. They cooked the books by inventing a curve fit and saying it was a physical phenomenon and named it celestial refraction. And that's how they maintain the globe. And that's why they have a different celestial refraction formula for every single angle band from 0 to 10 degrees, 10 to 30, 30 and up. And then they have an approximation for all of them that doesn't work as good as the individual ones, but generally works across the whole range fairly well. It's not even real. And yet that's what you guys have to do to fit the real world observations to the glob, because they don't work. If you just use, almost done. If you just use plain trig and you just use drop over distance, over 90% of the time it will be so much closer to the flat drop prediction. Or it's not the flat drop, sorry, the plain trig prediction, not the globe drop. When you add in celestial refraction, which actually by definition was just an empiricization of the error. It was a quantification of the error. All of a sudden, the error goes away when you multiply it by the quantification of the error. What do you know? And you get the globe that way.
So it sounds like you're. It sounds like you're agreeing with me that the method of timing and occlusion, putting stellarium on the peak with ATM off. It sounds like you're agreeing that that method does not exclusively match arctangent of rise over run and is not exclusive to flat Earth.
Jesse, if that's what you heard out of what I just said, you are either totally inept at the English language or you are just engaging in purposeful subterfuge every time you open your mouth.
So, do you think it does always match arctangent of rise over run then? I mean, either you do or you don't.
Jesse, you are completely not addressing anything I just said, bringing up something different and trying to change the conversation to be about that. You are definitionally bad faith, and this is why you get banned from the presentation commentary, because you always do this. You see, when you're in a conversation and someone is addressing your paradigm by positing factual historical information about the development of it, and then you just sidestep their entire 2-minute spiel explaining it to you and ask them dumb questions like this, it demonstrates you are not actually here to learn anything.
Well, I mean, I appreciate you sharing your views on how you think the globe is faked, but I was talking with other people about this thing called the celestial theodolite, and you did pipe up about that to me, and I'm asking you if you think it is a valid method for determining the true angle to the peak of a mountain or not.
It gives a result that in almost all cases, except the narrow range of cases, specifically where the half angle over the midpoint on what's supposed to be a globe curve, except for where that comes out to be approximately similar to the actual drop over distance so that those two cancel one another out. Except in those cases, it approximates extremely close to the flat earth. Yes, usually within about 2 or 3 arc minutes. And those
But
2 or 3 arc minutes that it's off by, which are much less in most cases than the globe is in most cases, which is usually 10 to 15, is evident that there is evidence that, number one, it fits the prediction better, but number two, there's still optical phenomenon happening within our spatial field that render everything we look at not as perfectly straight lines. There is nonlinear compression close to the atmosphere. We see in non-Euclidean space. This is obvious to everybody who understands optics and the laws of perspective, but that is more than enough to account for those slight variations from ideal predictions. And your model, though, you have no reason to be so wildly off. And especially once we look at things like Alan's spreadsheets and Dr. Mike's measurements that they took, when we have I don't know, just a bunch of random mountains that just happen to be close to where people live, over 50 measurements, and almost all of them match within the 95th plus percentile to a plain trig prediction. Yeah, that's pretty good evidence that it's a better explanation than the globe.
except they're not all a match for flat Earth. Like even
I didn't
Pike's.
say all. I said 95%, bro.
Well, hear me out. Hear me out. I'm responding to that. Pike's Peak is not even a match. I don't know how much you know about statistical matches, but if you take multiple measurements from multiple days of Pike's Peak and you get the standard deviation and the average, they're actually none of them are spot on. They're all off to one side of reality, and the average is off from reality several standard deviations. That is statistically not a match. And Blodgett Peak, and this is going to take a little while because I need to go over these. Blodgett Peak is about halfway between, slightly closer to globe. That's not a match. That's a half a dozen data points at least. Cheyenne is slightly closer to flat, but again, about right almost halfway between them. Mount Rosa, of course, is spot on. And then, of course, Greenhorn Mountain was at least 1,800 feet in error. So it's like to say that they're a match. And then, of course, the two Blinn Mountain ones were both closer to globe, on the other side of globe from flat. So to say that 95% of them were a match to flat Earth is not true. Halfway between is not a match to either. It's just not a match. You cannot claim that as a match. Even if you want to be, I'm almost done. Even if you want to be statistically sloppy, halfway between is not a match for either one. And if you want to be technically correct, Pike's Peak is not a match because it's outside several standard deviations. Go ahead.
Yeah, every time someone in here engages with you, you do this thing where you manipulate what they said by selectively changing details in small ways to conform to a different actual statement that you want them to have said so you can attack it and use it. I specifically told you that the measurements, most of them, the majority of them were within the 95th percentile. Because when you are predicting 231 and you get 233 and you're off by 2 arc minutes out of 2.5 degrees, you're well within the 95th percentile. And furthermore, you also keep saying it's a match or it's not. That's not how it works. You don't say it matches 0.00000 nth degree of precision and it's a match or it's not. That's not how any measurement works. There's imprecision in every measurement, as well as external factors that affect the measurement, so to speak, variability. But once again, Jesse, we all already know this because we've been going through this since March. You're not telling anyone anything new. My point to you was this. What I just described about celestial refraction, you still haven't addressed. So I'll frame it another way, Jesse. Let me frame it another way. Let's say that I have plane trig predictions, because we do. We have plane trig predictions for 50 something different celestial theodolite occlusions. We have over 50 occlusions, right? And we have plane trig predictions for all of them. Let's say I was to take the idealized plane trig predictions for all 50 points, and I'll plot those on a curve. And then I go take the actual measurements that Dr. Mike and Alan and everybody else took, and I'll plot those on another curve. And I say, look, the real world predictions are not perfect matches to the ideal plane trig predictions. You know what I'm going to do? I'm going to take the difference of these two curves. I'm going to subtract them from one another and see what the magnitudes are that are left over. And then I'm going to put that difference in Microsoft Excel. I'm going to plot a quadratic curve fit to it, and I'm going to have it spit out a second order polynomial. That's a magic polynomial. So now, anytime I go to any point that I actually measured, I can multiply any of those points by this second order polynomial, and it's going to transform my measured angle to the ideal plane trig angle. Look, I'm going to name it. I'm going to give it a name. I'm going to name it planar refraction. This is your new planar refraction formula, because the stars, Jesse, they experience something called planar refraction. So you got to account for it anytime you take a measurement, don't you know? Would you accept that, Jesse? If I presented that to you as a way that I know that the Earth's flat, would you accept that as proof of a flat Earth?
Well, it'd be something I would want to test, but at least you would be making some effort to correct the method to match reality, which I would have a lot of respect
Jesse.
for.
The answer is no. You see, everyone just saw what you just did. You just exposed yourself. Thank you so much for not giving the obvious, honest answer of no and trying to double speak so you can preserve celestial refraction, because you know exactly the point I'm making. That's exactly what your side did with celestial refraction. That's definitionally what it is and how it was invented. But you don't want to acknowledge it wouldn't work for a flat Earth, but you can't say that because then it wouldn't work for your model. So you try to take this weird double speaking middle ground and you say, well, at least you tried. No, the answer, Jesse, is no. That would not be valid. It wouldn't be valid for us, and it's not valid for you, yet it is incorporated into the mainstream model for the globe. It is proof and evidence that you guys have been cooking the books for over 100 years. And most people just have never looked into it to know this. We figured this out, though, thanks to the fact that you put it in your simulator. Then we pulled it from the actual textbooks and historical data to figure it out. So thank you for helping us sharpen our toolkit. We appreciate it.
Certainly. But I feel like you sidestepped my last point. I went over Blodgett, Cheyenne, Greenhorn, and Blinn Mountains. Can we agree that Blodgett Peak does not match Flat Earth because it's slightly closer? I mean, yes or no? Look.
Yeah, Jesse. This conversation you're attempting to have has been had, like, what is it, 31 times? That's not what I'm seeking to engage in. I was trying to giving you an opportunity, at least. I knew what was going to happen. I was giving you an opportunity to respond in good faith with everyone here in the room here to listen, to give everyone some slight semblance of some indication that you're actually willing to reason with other people and with yourself as to the potential, but just potential, maybe not actual potential, non-validity of the empirical position your side takes. But you were not willing to do that, and you just want to play the broken record over again. So I'm going to disengage now, but I hope that it was edifying for the room to know just exactly where your actual optical paradigm came from and what they invented, i.e. celestial refraction, to force real-world measurements that didn't match the globe to make it fit and match it. Thank you.
Thank you. And I was really trying to give you a chance before the room, in front of the room, to show good faith conversation, but you refuse to address the actual data. You refuse to address which of these data points you think is this 95% that match flat Earth, and it's really strange how all these people claiming to be in good faith but throwing shade on me absolutely and utterly refuse to actually go over the data. And the reason,
Jesse, you put me on a wild goose chase last time.
I'm almost done, Rick. And the reason
We
is,
refuse.
hold on, dude. How did you get a driver's license without learning to take turns? So the reason is that nobody will go over the data with me is because they all know that it doesn't work. Go ahead, Rick.
Your head is so because. I mean, dude, the reason why I wouldn't do it with you is because just before you were belligerently lying. You said, like, you sent me on a wild goose chase to go check up with Alan whether or not they use individual corrections for each observation. You said that. You sent me on a wild goose chase. Why would I respond to you, Jesse? Why would I, like, now I come back to you, I say, hey, that's not what he said, and now you change your story. You said, oh, they did at one point. What's the go, Jesse?
So
You expect people to really, like, follow you up?
Did you go to Alan and he said no such thing ever happened, or what happened?
No, he said, he didn't. He basically said, no, dude, like, we've got, here's the formula. And he sent me the video with the, what is it? That anaconda chick or whatever.
Let me see if I can find a spreadsheet that shows a copy of Dr. Heffron's spreadsheet that shows those corrections. I thought I
okay,
did.
so is your
you
claim now? No. During that conversation, dude, you said that they were currently doing it. I asked you. I double checked, tripled down. I spoke with Rigger at the same time. We were like, yeah, we're going to keep an eye on this Jesse fella. You think that we'd just forget that? Do you think that you can just shift the goalposts like a little bit and sort of say, oh, well, you know, like they did it at one point and that's what I meant or something, which you're not actually saying. You never
Just
say,
go
like,
back.
correcting yourself and say, I accidentally made a mistake in my speech. You said that at the time that they were using independent refraction calculations for each observation.
Go back, get the recording. I'm telling you, I told you exactly what I'm telling you now, that at one time Dr. Heffron used it. That's all I said then. That's what I'm telling you now. And I'm quite sure I even gave you a link to Dr. Heffron's spreadsheet that was using
Why would it even be relevant to the conversation being had at the time that you should bring it up that they did it at some other point in time when they did it several months ago? The conversation happened a week ago.
Because the topic was whether or not they know that there's these huge errors in the data. And I presented as evidence of them knowing, I presented evidence that they had at one point put fudge factors for each and every one of these data points to make it match a flat Earth. So how could they possibly not know that there was these huge errors if they had manually corrected them one by one?
Out of curiosity, if you were developing this, right, and you were wanting to sort of, you want to work out what is the variability between each one of your observations. So in order to do that, you actually do need to apply fudge factors because you want to see what needs to be fudged in order to get it to align perfectly, right? So that would then tell you what your variability is.
Okay, did you check out the spreadsheet I sent you last Monday? Yes, no, don't remember.
The spreadsheet that you sent me last Monday.
Yes. Last Monday, I gave you a link to Dr. Heffron's spreadsheet from 2025 07
Where did you give it to me?
Right here in this very chat, and I tagged you with a
in the live stream you gave it to me?
Yes.
Yeah, like, why would you expect me to just pick up every single notification that comes through?
I mean, I can tag you.
Thanks for just, like, writing. You may as well just post it somewhere, dude, like, randomly. Why would you tell me that you gave it to me and not, like, have it be a DM or something? Dude, the squirrely language that you use, it's just, I don't know if I can be bothered anymore, man.
Well, I mean, I didn't know that you didn't check your tags. I check my tags. I searched to see who tagged me when I was away, and I tagged you with that, and there's proof of it. Okay, it's recorded. Last Monday, when you asked this same question, I tagged you with the same, or when you asked about it, I tagged you with the actual spreadsheet data from Dr. Heffron that has those corrections in it. So I don't know why you're saying you went to Alan. I guess I'm sorry you didn't get your tag. I thought I
No,
told you that
I said to you multiple times, I'll go check in with Alan. I'll ask Alan.
Okay, what did
Don't
Alan?
pretend like you didn't know that wasn't going to happen.
Okay. I got a question for you, Rixky. Did Alan tell you that yes, Dr. Mike was doing that, but that Alan's no longer doing that, or did he pretend I just was just making stuff up? Tell me honestly. Was he honest?
I asked, how would I know whether he was honest or not? I asked him, did you apply independent corrections, or are you applying independent corrections on each one of these observations? He says no, and then shows me, here's the data. So are you expecting him to put in a qualifier or something to know that at some point that they were previously applying the corrections independently?
Well, just for your information, he did know about those. It was a big contention point between him and Dr. Heffron. And
how would he know that I've got the context, and then for you to imply that that's dishonesty on his part? I don't even know how you've survived. Like, how many mates have you got with this attitude and this squirrely little language that you do?
I'm not saying he was dishonest. I'm just saying he did know and he did not tell you. I don't know what exactly.
Have you ever found yourself having to get out of some problem at the work site or something, and you just blame that someone didn't put this bolt back properly? You got to get really good at this, just little excuses all over the place or something.
Demons, Rick. Demons.
You have. So I don't know why you're saying you went to Alan. I guess I'm sorry you didn't get your tag. I thought I told you.
I said to you multiple times, I'll go check in with Alan. I'll ask Alan.
Okay, what did
Don't
Alan?
pretend like you didn't know that wasn't going to happen.
Okay. I got a ski.
2 ad homs?
Cute ones, you know.
Hey, attacking
the person rather than the argument. The argument at the moment, for as far as I'm concerned, is what you said, what I heard, and then trying to come up with the accountability of the statement. So, yeah, I mean, it's not quite an ad hom because the topic of conversation is literally how sort of viable your statements are, how truthful they are.
Your memory. Just a second, Gatebreaker. Right. I'll hand it off to you. Ricksky, your memory of what I said is wrong. Just go back to the timestamp of that thing I just replied to for you. I tagged you again, by the way. You can click the message that was in reply to and get the time that I gave you that spreadsheet. That'll give you the time that the conversation happened a little while before that. So go back, get the recording, and come back and do whatever, okay? But I'm telling you,
yeah, and then I got to transfer the times. I got to work out.
Dude,
it's the American time versus the Australian time. So hard to track, eh?
I've seriously got no reason to misrepresent what happened because it's all recorded and I know it. So get your receipts and come back. I told you straight up how it was then. I'm telling you straight up how it was. And go ahead, Gatebreaker.
Thank you. Sorry, I got food in my mouth. 1 sec. All right. This question's for Jesse, real quick, or one of the flat earthers if they want to. In this experiment that we've been doing with the Heffron method and everything, do the stars' real GPs have is it a factor in this?
No.
Okay, that's
what
all I
do you mean by is it a factor? What are you asking? Can you can be a little more clear with your question? Sorry, I'm not quite getting what your question.
I'll just get to the point. Thus far, we haven't covered the southern hemisphere yet, and the Gleason model that doesn't have GPs for the southern hemisphere stars, and I was wondering if that could possibly be a factor in the southern hemisphere.
What do you mean it doesn't have ground positions? Are you saying when you're in the north?
No, the southern stars, they don't have true GPs.
What do you mean?
Because okay, so imagine the globe, and then outside of that, a celestial sphere with each star mapping to a point directly over it, right?
Yeah.
Okay, well, on the globe, Antarctica is at the South Pole, and the southern axis of rotation and the southern stars are directly over Antarctica, the GPS. And
Uh-huh.
what the Gleason map is the globe is splayed apart at Antarctica, and that southern axis of rotation has been put at the other outer edges of the world, and
I
that's
get what you're saying.
yeah,
So
yeah. So
I guess what you're saying then, because what you would still do is you'd still just go to Stellarium and go to your GPS coordinate system because it's all based on the graticule, right? The geoid model, right, and the ellipsoid model that they fuse together are just ground projections of the graticule onto a terrestrial sphere. So ultimately, you would still use the same method. You would go just take a star occlusion in the south the same way you would in the north, and then go into Stellarium and get the nautical almanac value for the true position and compare it with the peak and the ground observer after shifting positions and compare it to plane trig and spherical trig. You'd still do it the same way. But I guess what you're saying is you're predicting that like the method wouldn't yield results even anywhere close to plane trig if you were to go do it in the south. Is that what your guess is?
I, I I don't know this as in depth as you guys do, and I don't claim to. I just know on the Gleason map, there's going to be a time at night where two opposite sides of the world are going to see the same southern stars. And if you were to do simultaneous occlusions of mountains, it just something would be off. It wouldn't make any sense.
Yeah, I mean, south is every direction from center on an azimuthal equidistant projection. So you could have a person, in Africa and a person a person in Australia and a person in South America looking south at like the same star is what you're saying, but they obviously are having it blocked by two different mountains. And how could they both, are you saying like how could they both be having the same star blocked by mountains that are looking in different directions away from each other? Is that what your question is?
No, not really. I'm just really curious on when we'll move to the southern hemisphere, because regardless of like what Jesse's saying is like this is wrong, and then the flat earthers are saying no, Jesse's each side's claiming they're wrong, but as it is, it seems like that the flat earth is this is ignoring what Jesse said today. The flat earth seems to be coming up with more closer to accurate results, and I'm just curious if that'll still be the case when we hit the southern hemisphere.
Well, so none of us live in the South, right? And what they're doing is they're putting out like bounties to people who are like South American and Australian flat earthers or just researchers that are curious to perform these occlusions for us and take measurements for us and get good footage that can be used. And they're giving cash prizes to people who will do that. So like they're trying to get them, man. Like we can't really afford to just go fly to South America and point some cameras at the sky for a week and then come back and hope it all works out. Like, we all have like, jobs and things to do with our lives in the meantime. But, we're trying to do that. It's a fair point. Like, we want to see those measurements too, for sure. But I don't expect that there will be any significant changes. I suspect that the method will continue to have the same degree of accuracy in the south as it does the north, because ultimately, uh, the topography of the ground that we live on, the map that we're given to describe it, is all just from the same graticule. The lat long system itself comes from that. The definition of a meter comes from that. The definition of a nautical mile comes from that. It's
Do you
very. Huh?
do you think the global model having actual GPs of the stars for the southern and northern hemisphere would be an important thinking point over the FE version?
Well, it's definitely like a good question to ask, right? Like, I don't deny that in your model, right? You treat everything as if it's like physically there. Like that's how the graticule is built, right? They attempt to create a terrestrial sphere in order to make a 1-to-1 zenith to ground point coordinate system called the graticule. But ultimately, like most of us believe that the stars that we see are projections. And so like if you're in the south looking at southern stars, I don't know if you've seen like the effects of like a coffee cup
Yeah.
caustic, or with the inner reflection patterns of a hemisphere dome, and the way that they
Yeah.
trace and then the arcs wrap around and have they have points that are 180 degrees offset from one another at the appropriate distances from the surfaces of the hemispheric domes. So like if something like that is happening, if there's like a light source above, right, and it's projecting light down and it's coming out at one point on the dome on one side, and then in a caustic manner wrapping around the hemispheric dome goes around to the other side and has another point that's a reflection 180 degrees offset from that one, then now you actually have all these southern stars actually have like 2 points, right? And people can see them at either of these two respective points on two different sides of the earth.
At
So
a
so
at a better time, because I didn't want to take the mic away from Jesse for too long. This
oh no,
specific topic,
please do.
no, not today. What I was gonna say is, let's talk about this later at another time, because I've actually tried to model this, and I'm very interested in it, and yeah. So let's talk about this directly. The Southern Stars, at a later time. But I just wanted to respect Jesse and what he's been talking about for the past couple hours. Sorry, Jesse, I didn't mean regardless of Jesse, like I was dismissing you. I was just saying, just for my question, I had to put to the side what you were talking about. So,
Oh, that's
Jay,
okay.
Before you go, Gatebreaker,
yes.
just I recommend you, bro. Like the little explanation that I gave the room about celestial refraction. You should go, verify everything that I just told you guys and fact check it so that you can be confident in it, right? And then, ask yourself, the question that I asked Jesse: if I was to uh, take 50 different points on the Earth and make 50 different theoretical predictions of what a flat plane would predict for a cell Theo occlusion, and I went and measured it, and I got 50 real measurements, and the 50 real measurements were all just slightly off. And then I quantified the error between those two curves, and I did a curve fit in Microsoft Excel of that error and spit out a second order polynomial, a quadratic formula, so that I could take any of my measurements, multiply it by that quadratic formula, and transform it into the ideal measurement. Would you accept that as a real scientific approach to say, oh, there must be something physically happening called planar refraction that's causing the light from the stars to slightly bend as it comes across the plane? Would you accept that as a real scientific explanation?
With the amount of what you're asking me about, the globe version or the flat version?
No, the one I just made up was the flat version.
Yeah, with the amount of work I've personally done for the Southern Stars in the Gleason map, I would need to just words won't be enough for me. I would need it demonstrated or like 3D modeled or something, because I've personally tried to do that. So to answer your question, for me personally, no, it wouldn't be enough.
Well, the point, okay, I think that there's like a little bit of missing the point of the question. So, like, yeah, you're
I get
saying
it.
it
I
wouldn't
get
be
it.
enough.
Like the Glober Southern, the Glober Celestial Navigation. I think you mentioned it earlier when you were debating Jesse. It's kind of like supposedly ad hoc corrections to match the reality or whatever at every point or something like that.
So yeah, so celestial refraction. So to be clear, celestial refraction. I just made up something called planar refraction, which would just be I literally copied exactly what celestial refraction is for the globe, and I just made the mirror version of it on a flat Earth, right? But what I was saying is that all I did, I took a bunch of real world measurements. My real world measurements did not match my predictions.
So I created a formula, a magic formula where I could take any of my measurements, multiply it by the formula, and it would transform it directly into the ideal prediction. Right? I didn't measure the ideal prediction, but I have a magic formula. You can just multiply a bunch of random coefficients in there, and it'll turn it into the prediction. Post hoc, right? You would never accept that as a real scientific explanation of a physical phenomenon that's happening up in the sky. That would be absurd. But that's precisely what celestial refraction is. That's what is being done to all measurements everywhere with respect to the stars. They say you have to apply a celestial refraction correction because the fact is that using the 8 inches per mile squared geometric drop doesn't work. And so my point in revealing that is for people to understand that it literally is an ad hoc quantification of error, and they're taking their quantification of error and pretending it's some physical phenomenon that's not actually able to be physically substantiated. There's no general formula. In physics, anytime a physical phenomenon is occurring in nature, you have to be able to create a general formula to describe it in order to prove a cause and effect relationship. If I can create a general formula, such as, the laws of electromagnetism, for example, I can prove that there's a cause and effect relationship. They don't have that. There isn't even a single unit, a single variable at all in celestial refraction. It literally just takes an input angle and spits out an output angle by multiplying it by a random set of numbers.
Jesus, I would love to respond to this. If
Hey,
other people.
I just wanted to close it. Thank you for your explanation. I'll hand it over to whoever wants to go next. I appreciate it. Hey, I hope we could talk about the flat Earth Southern Stars in more detail though at a later time. Thank you.
QOP has an argument that he would like to say, but he's muted if anyone wants to get to that at some point. Thank you.
Can I just respond to what was just said to finish the topic?
Yeah, go ahead.
About the celestial refraction. Okay. Is my microphone good because I'm on my phone?
At some point. Thank you.
Can I just respond to what was just said to finish the topic?
Yeah, go ahead.
About the celestial refraction. Okay. Is my microphone good because I'm on my phone? I'm not sure. Okay.
You don't have to read the paper to know what it's about or that it tells us that we're wrong.
I mean,
because you can read the abstract.
Yeah, exactly. You can read the abstract. Your claim was very basic. It was very broad, which is just the statement that there is no derivation based on physical laws of astronomical refraction. And here's a paper that's entirely about it. Right? I don't need to be an expert about how physics works in order to see what the topic of paper in general is about, and that it debunks your claim.
So can you show me a formula in this paper that uses a physical variable such as temperature or pressure, right? Something that's not a non-physical variable such as angle or distance or height or index of refraction. Because index of refraction applies to terrestrial refraction, right? So when we talk about Jesse's simulator earlier, what he did, the way that it's done is you use terrestrial refraction to get an index of refraction. You apply that first, and then you plug that into the celestial refraction formula, which just manipulates the resultant angle. So if I read this paper, are you telling me it's going to deal with some variable other than angle and other than an index of refraction that comes from terrestrial refraction?
Yes, although you already excluded the index of refraction from the variables that you allow. And in my opinion, that's dishonest because index of refraction is already calculated using those values that you said. So if it just already assumes the index of refraction, this is not because it's some kind of arbitrary number, but because it's been already measured by other scientists, right? It's not really hard to do in a lab, depending on those different conditions, right? Depending on pressure, depending on temperature. So if you have an index of refraction, then that already has temperature and pressure baked in because it depends on those values.
I want to go to the abstract of this paper. Astronomical observations near the horizon have historically been made for naval navigation and determining the time of sunset. Recent applications include near-horizon daytime scene simulation to support infrared search and track and seeker studies. The ray path of the setting or rising sun can be highly distorted near the horizon, and it is seldom rectilinear. Oh yeah, like it's not Euclidean, it's not straight lines, right? An accurate model of atmospheric refraction must include the observer's altitude as well as range, frequency, and atmospheric pressure and temperature. At infrared through ultraviolet frequencies, refractivity depends strongly on the vertical temperature profile, and an explicit relationship between refractivity and temperature can be obtained. This article describes a refraction model we developed that closer reproduces the profile of the setting sun. Bro, this literally says that they're measuring atmospheric refraction as it applies to sunsets.
Bro, it's amazing that
Refractivity of a
you guys
standard
can like
atmosphere.
push. Yo, you guys push like CELTIO, like straight lines to stars, and then now you're debating a glober saying that you can't draw straight lines to sunsets. It's great.
Wait, I'm confused. You just described all of the variables that you wanted. You just described that they include the pressure in the model, they include the vertical temperature gradient, that they include the height of the observer. That's all of the
Atmospheric
variables that would be.
refraction, bro. Atmospheric refraction. That is
I mean,
different from celestial refraction.
well, no, it isn't. Atmospheric refraction just means any kind of refraction that happens in the atmosphere. So terrestrial refraction and astronomical refraction are
So
just. Let me
look,
finish.
buddy,
Let me
look,
fucking
you
finish. You're already
do
having a
this
meltdown, bro.
all the time.
You're
You
already getting triggered. You cannot let me finish my
Yeah,
sentence
because
again.
you try to conflate what I am talking about with a straw man you have built and to then attack it.
Okay, how can you know it's a straw man if I didn't finish my argument yet? Maybe my final argument after I finish my sentence will be different than the part you
If
cut
you
off
look in the
and
chat,
try to
Alan has
address.
dropped the paper that shows how they historically derived astronomical refraction. A
Mhm.
determination of astronomical refraction from physical data.
Okay, so again, atmospheric refraction. Atmospheric refraction just means any kind of refraction that is caused by atmosphere. So terrestrial refraction and
Specifically different.
astronomical refraction. Okay, I will talk over you. I will talk over you. I will talk over you. I will talk over
We're
you.
going in circles,
Talk
bro.
over you. I will talk over you. I will
Hey,
talk
can we
over
just
you.
reset? Can we just reset? Let the poet go first, and then please continue.
Then let's just. I want to finish my argument, but he's interrupting me. That was already my second attempt.
I just keep the floor for you, bro. Go ahead and take a minute or so.
Bro, again, atmospheric refraction just means any type of refraction that is caused by atmosphere. Terrestrial refraction and astronomical refraction, they are just types of atmospheric refraction, depending on if it happens to an object that is outside of the atmosphere or inside of the atmosphere. That's literally just the difference. It's a division by cause, but the mechanism is the same. And
Yeah,
in this case,
so you know that when you say atmospheric refraction and you define it in the way that includes both terrestrial and celestial, that means that atmospheric refraction is going to do terrestrial refraction. It's going to do the terrestrial part, and then it's going to add the celestial part to get the total, right? Which is what I said earlier is what happens, and you're acting as if you're contradicting me and proving me wrong somehow.
No, No, your argument wasn't this at all. That it includes both. Like, I do agree with it. Your argument was that it's derived completely baseless based on just observing what the angles are and then plotting a curve that matches the observations the best. But this is false. We have a model
Let me
for
tell you
this.
one more time what my argument is, because you still don't seem to know. My argument is that celestial refraction. Stop saying atmospheric, because you already defined atmospheric as it includes both terrestrial and celestial. Okay. I was not using your category. I was keeping them separate from one another so that we could look at what they do. Okay. Yeah. If you just want to say atmospheric, everything that happens in the atmosphere, starlight comes to the atmosphere, thus celestial is atmospheric. Fine. Cool. What I said was you first take terrestrial refraction, which accounts for things like temperature and pressure and all the physical variables, and is very real and has a general solution that has been worked out and explained and measured for centuries. We know it works. Okay. So you do that first. Then you get an angle that results from that. And guess what? It still doesn't match reality. So you then have to take that angle and plug it into a celestial refraction formula, which does nothing physical to it. It just manipulates the angle into a different angle to fit the prediction. And you're saying, no, that's not true. Here's a paper about atmospheric refraction, which includes both. And when you calculate atmospheric refraction, you use the physical variables too. How does that contradict what I said? Do you comprehend what you're reading?
Uh, so this paper is actually about astronomical refraction. It's just that it uses the word atmospheric refraction for here because it doesn't make this distinction, but the entire context is about a solution for an object that is outside of the atmosphere. I mean, if you want to have something that is inside of the atmosphere, then you will need a slightly different solution simply because it doesn't travel throughout the entire gradient, but just through a smaller part of it. So it will be still based on the most fundamental laws like Fermat's principle, but you will need a different formula for this application. This paper is about astronomical refraction, and it uses the word. It's about the celestial refraction, and it uses the word atmospheric refraction simply because people don't really make that distinction as much as you do. It's obvious from the context that it's about, the celestial refraction.
So let me I just told you what my claim was. So do you have something that specifically refutes my claim that, once again, historically, the way that they originally came up with celestial refraction corrections is they started with a measurement, they applied terrestrial refraction, it still didn't match the prediction, so then they created a formula that was a second order polynomial curve fit to change the measurement into the prediction through the quantification of the error therein.
Oh, historically, you now change the claim that this is the first derivation that was made in history. And to be fair, I don't know if that's true, and I don't really care. I don't think that's relevant to our current state of knowledge. I don't really give a fuck about what some guy in the 1980s, in the 1800s, how he first came up with the first, most primitive formula for the atmospheric refraction, as much as I care about, I don't know, Copernicus' book in order to get our current knowledge about astronomy.
Mm-hmm. Yeah, so when I read this paper, right, am I going to see something that distinctly contradicts me where I said they first apply terrestrial refraction, i.e., refractive indexes, and then they do just a raw manipulation of the angle after that? Am I going to find something in here that contradicts that? You haven't read it, right? You said you didn't read it. You don't need to read it to know I'm wrong. Isn't that what you said?
Yeah, your claim, I think what you're doing now is you're slightly changing your claim, hoping that I will just accept this. I responded to this. I clarified that yes, that was at the beginning of the conversation, by the way, that yes, indeed the formula we'll find in practical applications like the almanac is just manipulating the angle, just plugging the angle in, and then you get the value of refraction. But the derivation of it, the way it came from, wasn't just that. It was actually derived based on physical models, right? And your counter claim was that there is no derivation. I showed you derivation. Now you're running away, and now you're saying that the formula itself is just a formula where you plug in the angle. Okay, yeah, but this is still based on more fundamental derivation. You previously said it isn't. Then I showed you the derivation. Now you're changing your claim. You're just saying that the final formula is just formula with one variable with angle. I mean, yes, but that's what you would expect from a formula that is derived of physics, right? It will just reduce to an angle because if you have constant conditions, then the only thing that will influence your refraction is basically the height above the horizon, right? Because when the star is setting, then you have a stronger gradient. It passes through a stronger gradient the lower it is above the horizon. So those conditions they change over the angle of the star. That's why it will reduce to just plotting in a single variable, which is the angle, because all other physical variables like pressure, temperature, they depend on the angle, right? That makes sense for me perfectly.
So I'm just going to read something from the results of this. We checked the results given by equation 7 by computing the angular deviation of an astronomical object observed through a standard atmosphere as a function of elevation angle. So, in other words, we took what we see through a standard atmosphere, which is your standard atmospheric correction, which is refraction, terrestrial refraction, and we noticed it has an angular deviation from that, and that deviation is a function of elevation angle. So they apply a correction to the standard atmospheric model prediction, which is just terrestrial refraction, and that correction is a function of elevation angle, which I literally have said like over 5 times earlier tonight, as well as within this conversation combined. I still do not see what you are showing that contradicts me if this paper is taking a quote unquote atmospheric refraction model where they explicitly combine both terrestrial and celestial refraction together in one formula. That does not mean that celestial and terrestrial refraction are not separate from one another. I don't understand where you think you are proving me wrong or what your point even is.
Okay, standard atmosphere, it doesn't mean terrestrial refraction. Standard atmosphere is just a model of atmosphere with the average temperature profile and the average pressure that we most commonly have on the Earth, for which we use for our models of refraction and of different stuff like that. So this isn't about observing those angles in reality. If you hear the word standard atmosphere, then it's basically an idealized model. This just means that they assume these atmospheric conditions, then they run the simulation through what if the atmosphere was standard, and then they got those resulting angles. And I mean, my point is basically that this astronomical refraction, it's based on laws of physics, right? This is maybe you change your point throughout the conversation because you got debunked, but originally your point was that this was just completely made up only by observations and that this has no basis in physics, right? And this is what I'm trying to prove that it has.
What do you mean by this? When you say this, what's this? You have to define this.
because you can't just keep using that term arbitrarily and switching back and forth, which is what you've been doing the whole time. Define this. When I said this is just quote unquote made up, not based on general principles of physics, what do you mean by the word this?
The formula for celestial refraction.
Yes, celestial refraction specifically as a separate component of atmospheric refraction that from terrestrial refraction.
Yeah, and here you have a derivation based on laws of physics of this formula.
It's not. Yeah. The proof of this was given to you in the chat. Go look at the paper. It shows the actual derivation for celestial refraction itself. Not a unified formula where they're combined together, which is what you gave me a paper of and pretended it was a proof against me. No, this actually keeps them distinctly separate from one another and shows where the celestial component specifically came from. And it's not based on the laws of physics. It literally is based on a set of measurements. It is titled A Determination of Astronomical Refraction from Physical Data.
Okay, so I'm very confused. Why would the terrestrial refraction be irrelevant to the model of celestial refraction? You don't, like when you're observing the angle to some celestial body, then applying terrestrial corrections is completely irrelevant to that, right? Because you just measure it of the astronomical horizon, and the
Hold on.
astronomical horizon.
Pause. This is a great question. I'm so glad you're bringing this up, bro. I'm so glad you're bringing this up. Before you've created a celestial refraction correction, before one exists, let's say we live before the year this was made. All you've got to you just took your terrestrial refraction correction. Okay. And now it doesn't match what you thought it should be. Now what do you do?
I don't. I would disagree with this premise. I think that's already based on a wrong assumption, because there was. I don't think, I may be wrong, but probably I'm not. I don't think that there was a terrestrial refraction correction before there was an astronomical refraction correction. I don't think this is how the history works, because both, right? Both. Like when you know that refraction happens in the atmosphere, then this just logically follows that it will happen to both the celestial bodies and both the terrestrial bodies. So I don't think that based on this simple fact, I'm going to just keep talking because I never interrupted you. Based on this fact, I don't think that humans were ignorant at any point in time where they just thought it's going to impact only the terrestrial bodies and not the celestial bodies, because
you just acknowledge that you have no idea what you're talking about. You might be wrong. You don't know, but probably not. But then you're going to keep talking and asserting yourself as if you know what you're talking about, even though the reference material is literally in the chat and you haven't even opened it.
I mean, I can open it, but it just makes a simple logical sense to me that
No, it doesn't, because you haven't even looked at the evidence of the claim. We gave you the receipts and you won't even look at them, but you want to assert yourself as if you're correct.
Wait. So this paper that you're quoting in this article, in this screenshot here, is a determination of astronomical refraction from physical data. The entire point of this paper, based on the title, is determining it from physical data, but the fact that you can determine it approximated from physical data doesn't mean that this is the only way to do it. And your claim is that
So you literally didn't read the paper that you gave me. You said I did a Google search, and in less than 90 seconds I found a paper that disproved you. I said, have you read it? You said, no, I don't need to read it in order to know that you're wrong, though. I can just read the abstract. The abstract was talking about atmospheric refraction, didn't even mention astronomical refraction or what you're talking about. And you said, well, atmospheric includes both. But you just wanted to continue pretending like the paper disproved me, even though it didn't. And now we're showing you our paper, and you're saying, well, I might be wrong. I don't know, but probably not. But I don't need to read your paper yet because I know logic and it just makes sense that I'm right.
Okay.
That's where we're at.
This paper, but those papers don't contradict themselves. They are just different approaches. One is you're having a meltdown. One is theoretical. One is theoretical and derives this from Fermat's principle. Another one, from definition, it's deriving it from empirical data, because that was the point of the paper. It's in the title, a determination of astronomical refraction from physical data. But this doesn't mean this is the only way to do it. You're trying to prove a paper that is focusing on this method in order to prove this is the only way to do it. And my paper refused your claim because it has a theoretical approach, because you have this paper existing that does it the other way. This doesn't disprove my claim at all. My claim is that, yeah, you can do it this way, you can do it that way. Doing it from empirical data isn't required, it isn't necessary. And the existence of a paper that does it empirically doesn't disprove the existence of the one that does it theoretically.
Yeah.
It's just different approaches.
You didn't, right? You looked at the title of the paper and thought that you could teach me, right? Right. Who's the dishonest one here again? Oh, okay. Yeah, here's the thing, buddy. If you were just to go look at these papers that we're providing to you, you would find that the resultant formula, you can just skip to the end at the beginning. You can skip to the end to see where the conclusion is, and then you can go back and read how we get there. The conclusion is going to give you a set of formulas that depend on what? That depend on the angle you observed and whether the magnitude of that angle is this far above the horizon or that far above the horizon. Based on how far above the horizon that angle is, we're going to multiply it by a specific set of different numbers in order to change it to a prediction it didn't match in the first place. That's literally what's happening. That was my premise from the very beginning. I'm still maintaining that premise. I haven't changed my premise. And you're sitting here floundering, trying to say that I can just look at the title of the paper and know that you're wrong. Please disengage and go read.
Okay, but what's the problem? What's the problem in it depending only on the angle? If this is what you would expect, if this was based on physics, the gradient is vertical, right? You have more pressure the lower you go. So when the star the star starts descending below the horizon, then the lower it gets, it will be physically passing through layers of denser atmosphere. That's why this equation will reduce to just an equation based on angle, because the laws of physics, the physical conditions, they will change based on the independent variable of the angle.
Yeah, you still have failed to meet the challenge. You provided a paper that did not meet the challenge. I asked you, can you show me a formula for celestial refraction that uses some kind of physical variable set? What you did was provide me with a atmospheric refraction that had terrestrial refraction baked into it, which was the source of the physical part. You need to produce for me a formula for specifically the celestial component of refraction that depends on physical variables, not atmospheric with terrestrial baked in, just celestial by itself. Show me celestial by itself and show me a formula for it that uses physical variables and doesn't just arbitrarily apply coefficients to an angle.
But this is literally, this entire paper I gave you, it literally focuses on celestial refraction. The entire solution is to a light source outside of the atmosphere. It doesn't mention a terrestrial object at all. In the entire paper. The approach is a solution to the celestial refraction.
I'm not even trying to be mean to you. I'm trying to tell you, like, respectfully, you're trying to argue about things you've already acknowledged you don't fully understand and somehow assert dominance over things you acknowledge you don't know. Stop doing that. It's intellectually dishonest.
So gaslighting is now your argument, is trying to prove your point.
No, you acknowledged
where is
it
your
by
rebuttal?
your own mouth. How can I be gaslighting you by repeating your own words back to you? That's nonsense. Just stop it. Stop being dishonest.
Okay, so again, I don't need to know, how physics works in a complicated way in order to know what's the topic the paper is about. And this paper, based on the abstract, is about the solution for an object that's outside of the atmosphere. It doesn't mention a terrestrial object even once. It is entirely a paper about astronomical refraction.
That was
And
my
refute this with an actual argument that's based on logic instead of gaslighting and fallacies. You
I've
cannot.
already explained multiple times why that paper does not meet my challenge, and you just keep going in circles. This is not going to work. You're going to keep doing it. There's no point for us to continue. We are at a philosophical impasse and an intellectual impasse until you actually go read.
No, because your rebuttal were baseless. You said that there are no physical variables. It's literally based on physical variables. You read it yourself. You read the abstract. It mentioned vertical temperature gradient. It mentioned temperature. It mentions every single physical variable that could be relevant to the subject. And you read the abstract proving that, and then you said there are no physical variables. It
You're
literally
doing the thing I
represents
just said
physical
you would
variables.
do. Stop.
Bro, this is entirely a paper about the model you requested. There's a derivation. There's an object that's outside of the atmosphere.
Can you repeat back? Wait, no. Repeat back for me, please, Steelman. Please, Steelman, for me, what my request was.
A formula for only astronomical refraction that doesn't have anything to do with terrestrial refraction, and which is derived using actual physical variables instead of just angles.
Yeah, so when you take a model such as atmospheric refraction, which you already acknowledged merges together both of these two components, component one being terrestrial, component two being celestial. When you take a model that has already merged these two components together, you cannot say, hey, this model proves that the one component, celestial, by itself uses these variables directly. That doesn't work. You need to show these formulas separate from one another, not in a merged sense, in a simplified formula that merges them together and does all the work together, but one which uses one and then the other. Because I'm telling you, all of the physical components of refraction are wrapped up in the terrestrial formula. None of them are used in the celestial one. And you just want to say nuh-uh and pretend a paper that merges them together somehow refutes what I said.
I mean, this isn't merging them together. This is a formula that's for an object outside of the atmosphere.
Okay,
This is
I'm
actually
going to disengage now. This is a huge waste of everyone's time.
so you lost.
Keep doing.
You lost, and now what you're going to do is to gaslight me, trying to say that my argument was bad without actually refuting why it was bad, and just like saying, you're wasting my time too much. I'm going to disengage. Your argument is so stupid. Like, I mean, yes, that's just a rescuing device. You couldn't refute it using actual evidence, so now you're trying to say it's so stupid that I'm just going to disengage because I'm wasting my time. This is just a method to escape without actually refuting with logic.
Yeah. Yeah, you have invincible ignorance, buddy. No one can argue with you because you have it.
And you're constantly interrupting.
That sounds like a very strong projection to me.
It's really painful to listen that you are constantly interrupting, and it's really hard to understand the claims that Amboss are actually doing while he is absolutely listening to your shit that you're bubbling and never interrupted once.
That's a cool story, bro.
Could I
Thanks for
squeeze
coming in.
something?
No, it's not a cool story. You are constantly interrupting. You're not letting him out once a concise statement because you're always over talking. It's
Yeah, that's
really a
not
shit
true.
show.
he got plenty of concise statements out at some point when all he does is literally just go in circles, strawmanning and conflating my statements and repeating ad nauseum dogmatically the same things he's already said 3 times, which I already refuted. He needs to be interrupted because he's just literally wasting everyone's time. You
No,
go
you are
beyond, you
wasting
go
time because
beyond the
you are
constraints.
monologuing
You
all the
go
time for
beyond the
several minutes.
constraints
It
of
timed
good
you
faith.
once for
You're interrupting me now. You're interrupting me now, right? You want to play the hypocrite by accusing me of doing something and then literally doing it to show me how virtuous you are? That's cool. Yeah, he goes beyond the constraints of good faith within a conversation to the point of extremity, where once you do that so many times, in order to rein the conversation back in, someone has to forcibly take the microphone from you and say, hey, let's try to break this down and be honest. It's not like I was just railroading him and insulting him. I was telling him, hey, man, like, you've already said that 3 times. Please stop strawmanning me. Please answer my challenge and my question directly. And he just went in circles. So that's why I disengaged from him. Like, we're stuck. We're not going anywhere. There's no point in continuing it.
Could I say something real quick, and then you guys can go back? Piezo, you questioned whether Alan had really said that the flat Earth always matched closer, and I DM'd you and tagged you with the clip of where he said that. If you wanted to hear him say that, that's all.
No, Ricksky questioned that.
Oh,
I asked you, are you saying that we don't? Why am I talking to you right now? Sorry. Anyways, I gotta go. People getting on my nerves. But yeah, thanks, Jesse. I'll check it out. Thanks, dude.